All right, we're going to continue looking at angles today, and we're finally going to get into radians. I think we encountered these last week. I mentioned how there are two different ways to measure temperature, like Fahrenheit and Celsius. You can measure distances in different units. Good morning. Anything for the office? I think we're good. Thank you. Have a good day. Maddie, can you do me a favor and shut the door behind you? Okay. All right, so we're going to take a look at radians today, but we'll get there in a little bit. On Friday, we were looking at how we can draw angles, starting with a coordinate plane, like where we have an x and a y axis. And we were looking at a bunch of different terms and vocabulary words that we're going to have to get used to and be familiar with their definitions. So I want to just take a second to review those, and then we're going to get into the rest of this section, talking about coterminal angles a little bit more and those radians. So just as a refresher, if I were to draw an angle of 215 degrees, I would start with my initial side. Okay, the one part of the angle is starting on the x-axis, the positive x-axis that is, and I'm going to draw an angle of rotation or arrow of rotation. 215 degrees is a little bit more than a semicircle, aka 180. So I got to go more than a half a circle of a rotation. And whenever my angle of rotation ends, I have that terminal side. So those blue lines in there are representing the angle, and then the angle of rotation is showing you the path and the direction of that angle. Once we have our angle graphed or drawn, we can possibly figure out the reference angle, how far we are to the closest x-axis, and I believe in this case on Friday it was 35 degrees. Okay, and after we looked at all three of these different angles, we noticed how they all terminated or ended in the same spot, and they all had the same reference angle. Okay, that was our definition at the very, very bottom of your page for coterminal angles. So we're going to take a look at coterminal angles a little bit more today. So speaking of coterminal angles, all of these are different angle measurements depending on how many rotations you want to do or in what direction you want to travel, either positively or negatively, but all of these land in the same spot. So they are classified as coterminal angles. Can we think about how these three angle measurements are related to each other? We know when they're graphed, they all land in the same spot. But can we find some numerical relationship, a number relationship between these three different angles? I'll give you a hint. Take a look at the difference, aka subtraction, between some of them. What's the difference between these two angles? What's the difference between these two? What's the difference between these two? You see it? Yeah? It's a difference of 360. If you take 215 plus 360, you'll get 575. If you take 215 minus 360, you'll get 145. If you take 275 and subtract 360 twice, you'll get negative 145. So coterminal angles, they all are in relationship pictorially, graphically, they all land in the same spot, but numerically, they all have some type of difference of 360 or multiple of 360. It depends on how many rotations you want to do in order to land in the same spot. So we're going to keep that in mind today as we pick up on the next page. Okay, so let's take a look at page 376. We're going to practice drawing an angle, okay, like we did on Friday, and then we're going to take a look at how we can find some other coterminal angles. So the first thing we're going to do is draw our little x and y axis. And we'll start with our initial side. That's the angle drawn, or not the angle, the side drawn on the positive x-axis. And since it's a negative 470, we're going to have to travel backwards. So that means with your pencil, we'll start on the initial side, and we're going to travel down, okay, through quadrant 4, then 3, then 2, then 1. So if we do a full circle, that's 360 degrees backwards, but we still have a little bit more to go because we want to go to 470. So the question is, how much further do we have to go? A full circle would be 360. If we go another 90, yeah? We need to do 20 more. All right, so 20 more is going to land us a little bit into that third quadrant, and we'll go ahead and draw that terminal side. I guess I'll make it blue, that way it's the same color as my initial side. Okay. So there's our negative 470 degree angle. We had to do one full rotation and then a little bit more. Let's go ahead and think about, can we identify the reference angle? How far are we from the closest x-axis? So that would be this left-handed side over here. Can we figure it out? Marie told us we had to go 20 more degrees into that third quadrant. So how much more would we have to go in order to get to that x-axis? Yeah, 70. Good. Each quadrant has 90 degrees, because 4 quadrants altogether would give us the 360, that full circle. Perfect. All right, so let's check this out. Can we find one positive and one negative coterminal angle? So can we get a different angle measurement besides the negative 470 that would still end in the same exact spot and therefore have the same exact reference angle? Let's see if we can think about that. Yeah.
250.
How'd you get it?
Because if you go 180 plus 70, which is the reference angle, you will get the same end.
Okay, so you can think about it that way. Okay, you can do that, those pieces. That's perfect. We also talked about how the coterminal angles all have a difference of 360 somehow. So if we take that initial angle we have, negative 470, and we add 360, and probably another 360, that'll get us to the 250 that Marie mentioned. Okay, if you want to double check it on your calculator, you can. So there's a positive coterminal angle. We have 250 degrees. So let's go ahead and try to draw what that would look like in standard form, okay, using this quadrant system to help us graph it. So we will start on the initial side, and then if we're going to graph positive 250, that means we have to travel counterclockwise. So if we go a half of a circle, that's 180. And then 250, or another 70 would get us into that third quadrant. So there's the ending terminal side. Notice how it's in the exact same position. So therefore our reference angle is another 70 degrees. 180 plus 70 would get us to that 250. All right, let's see if we can figure out another negative coterminal angle. Yeah?
We can decide 360 and get 110.
Negative 110. Okay, so you can take the 250 and minus 360. Okay, another rotation. You could start with the negative 470 and add only one full rotation. Okay, either way you'll get to the same spot, a negative 110. So let's see what that would look like. We would start on the initial side. Since it's negative, we're going to travel backwards, aka clockwise. So if we go one quadrant, that's only 90 degrees, but we need to get to 110, so we need a little bit more into that third quadrant, and we'll draw our terminal side. Terminates in the same spot, so we have the same reference angle. We doing okay? We're just adding 360 or subtracting 360. We just want to have some multiple of 360, and we can figure out coterminal angles. So there are infinitely many coterminal angles. It just depends how many rotations you want to calculate, either going positively or negatively. All right, let's take a look at radians. So just as, I don't want to say a heads up, but I know that our brains up to this point in your mathematical career have kind of been programmed for degrees, right? You learned about degrees probably in middle school when you're first talking about angles, okay? We are going to change our mindset, or at least try to change it, when we're going to be talking about radians. Because in calculus next year, if you decide to take that course, or some physics classes, they only use radian measures. So to kind of give you a comparison, you've been using Fahrenheit all of your life. If I told you from today we're going to start talking or using Celsius, wouldn't that be a little bit difficult for us to get used to? The same thing's probably going to happen with these radians. So it's going to take us some time, but we're going to practice and get used to them, hopefully, and or at least we have to get used to them for those of us that are taking calculus next year, because that's all we use is radians. So they're going to look different, but remember, it's just a different way for us to measure an angle, okay? So like I said, there's different ways to measure things, Fahrenheit and Celsius for temperature. You can talk about inches or centimeters for distances or segments. So we have degrees and radians for angles. So a radian measure is based upon something called the unit circle. This unit circle is probably the quintessential, most important thing dealing or involving trig. And we're going to get into the unit circle when we come back from break. If you learn nothing else this entire year, I want you to know the unit circle. That's how important it is. Okay? So, but we'll deal with that when we come back from break. By definition, the unit circle is a circle with a radius of 1 unit. That's why it's called the unit circle, just 1 unit long. And it's centered at the origin. So I gave you a picture kind of in the middle there, where the center of the unit circle is the origin, and notice how if you go 1 unit in any direction, that would be your radius. So we're going to investigate the unit circle just a little bit today to help us determine what a radian is, or what's this different way we can measure an angle. But we're going to get much deeper into the unit circle when we come back from break. So let's go ahead and try to find the circumference of a unit circle. Do we remember how to find the circumference of any circle? Little equation? Yeah. There we go. Okay. So by definition, if the unit circle is a radius of 1, what's the circumference? Yeah, just 2 pi. Okay, so it's a perimeter or circumference of 2 pi units. If you were to start at +1 on the x-axis and walk all the way around the unit circle, back to where you started, it would be a distance of 2 pi. Okay, inches, centimeters, miles, whatever unit you want to use. Okay, that's why it's called a unit circle. We don't really know what unit it might be. It all depends on the circumstance. So let's think about this. What must 360 be multiplied by to obtain the circumference of the unit circle? This is when we're going to try to figure out a conversion. Okay, you and Mr. Grashaw, I think his phrase is times in a line, right? Sound familiar? Okay, we're going to be talking about conversions. Because we are so familiar with degrees, we're going to try to convert it into a radian. Or if we're starting with a radian and you don't feel comfortable with that, we can always convert it to a degree, something you are familiar with. So we're going to try to figure out this conversion factor. Let's try to write this question in terms of a mathematical statement. What must 360 be multiplied by? So we can think about 360 times x. What do we have to multiply 360 by to obtain or to get the circumference of the unit circle, which we said was 2 pi? Can we solve for x? Divide 360, right? But maybe we can simplify this fraction, or at least the number parts. 2 divided by 360 would simplify to 1 over 180. So we'll have pi over 180. This is our conversion factor. Factor meaning multiplication. This is what we're going to use our times and a line to convert from radians to degrees or degrees to radians. All right, so let's go ahead and practice our times and a line. Mr. Gresham would be very happy. To convert from degree measure to radian measure. So let's go ahead and hypothetically say that we have some degree amount that we know, like 45 degrees, 30 degrees, whatever the case may be. What do we have to multiply by in order to get a radian? Okay, a radian is essentially the distance you have to walk on the circumference of the unit circle from that initial side to an ending point. So notice how if I were to draw this little example here, this might be a 60-degree angle, but what the radian is calculating is this distance, basically the arc length. So it's a different way of measuring it. Instead of looking at a specific angle measurement, you're essentially looking at a circumference or a distance measurement. Okay, so in terms of this conversion factor, the pi is representing a radian amount, and the 180 is representing a degree, because wasn't that 360 a degree amount previously? So think about what we have to multiply by over here. If we're starting with a degree, what do we have to multiply by in order to cancel out the degree? That way we're left with a radian. Yeah?
So in the numerator you would have 180 degrees, so the degrees would cancel. Well, on the bottom.
In the bottom. So if we're converting a degree to a radian, we would need a degree measurement in the denominator. That way these degrees would cancel. And we need a radian amount left over to represent the radian measurement that's equivalent to this degree. So that would be the pi. So in order to convert from a degree to a radian, we'll multiply by pi over 180. What if it was the other way? What if we were starting with a radian and we wanted to convert that to a degree? Somehow we got to cancel out the radian. That way we're left with a degree measurement. So the question is it still pi over 180 or does it change somehow? What do you think, Maddie? We flip it, right. This would be 180 degrees up top divided by a pi radian. All right, so it depends on your what you're trying to convert to, but notice how we're still using the same conversion factor. Just depends on what goes where. That way you can cancel out your unit. Okay, so let's go ahead and practice that a little bit. We're going to go ahead and try to figure out the radian values for these different angle measurements, at least for B and C, and then we'll try to figure out the equivalent degree measurements for the radian values in C and D. So if we're starting with a degree, we want to cancel that degree out. We would need a degree measurement in the denominator. And we would need a radian value left to represent the equal radian amount. So we would, if we multiply these fractions kind of straight across the top, you can think about 90 degrees is 90 over 1. We'll multiply some fractions. we'll have 90 pi over 180. But we could probably simplify those numbered values. What are we left with? Yeah?
1.57.
Okay, so if you were to type this in on your calculator, that would be the decimal amount. Perfect. Can I leave this with a pi in it? Can I simplify just the numbers, though? Yeah? Pi over 2, or 1 pi over 2. Perfect. Hey, Cade, do you need the notes? No, you're okay. All right, so there is the equivalent radian value. So 90 degrees is the same as pi over 2. So here's what's going on here. Maybe I'll draw it in our little example. We know 90 degrees is a perfect right angle, but what the pi over 2 is representing is how far you'd have to walk from that initial starting side to the terminal side, okay, how far you'd have to walk around that unit circle. Notice how it's still representing a 90-degree measurement, just in a different fashion. It's how far you have to walk around the unit circle to create that 90-degree measurement. Do we see kind of the difference between the two? I hope. Okay, so a degree measurement is measuring the angle, but a radian measurement is basically representing how far you're walking on the unit circle. But how far you walk is directly related to that angle in the unit circle. So these are connected to each other. Let's try the next one. We're going to convert a degree to a radian, so we'll multiply by pi over 180. This would be negative 235 pi over 180. And we want to go ahead and simplify those numbers. I'm going to show you how to do this on your calculator. Hopefully we realize that 5 can go into both of those numbers. We can simplify that. But I'm going to show you a little shortcut here. If you were to type in negative 235 divided by 180, we're just looking at the numbers, okay, not the pi part, you would get that decimal. Do we know how to convert a decimal to a fraction on these calculators? Check this out. Yeah, you know?
You go to math,
Okay.
and underneath math there's 1, which converts it into a fraction.
It's frac. Okay, so hit the math button. The very first option is frac for fraction. So it's going to take that decimal answer and convert it to a fraction. You'll get negative 47 over 36. I'm seeing some jaws drop. Like this was very useful. That's good? Okay. So this could be negative 47 pi over 360. Now keep in mind, your calculator can only do this for rational numbers, okay? Notice how if I hit pi, that's 3.141592, and if I try to do math frac, it's not going to convert it because pi is irrational. There's no way to represent it as a fraction. So you can try to convert a decimal to a fraction, but if your calculator won't do it, that means it's not possible. Okay, there's no way you can represent that decimal as a fraction. So just be aware of that. It might not work every time, but you can at least try it. All right, let's try the other two. So this time we're going to try to convert radians. Notice how the pi's are still in there, okay, representing a radian amount. We're going to have to convert radians to degrees. So this time we're going to flip that conversion. We're going to have 180 degrees over pi. So multiply straight across the top, straight across the bottom. 2 times 180 would be 360, and we still have a pi. Down below we'll have 3 pi. So what are we left with? Yeah.
120.
120. Notice how the pi's are going to cancel, and the 360 divided by 3 would simplify to 120. So if you were to walk 2 pi over 3 radians around the unit circle, that would be equivalent to a 120-degree angle. They mean the same thing. Do you guys want to try the last one? convert the radian to a degree? What's our equivalent degree measurement? Did you get it? Yeah.
Negative 390.
Negative 390 degrees. All right, so just looking at the radian, notice how if you just look at 13 over 6, isn't that a little bit more than 2, right? And we said 2 pi was equivalent to 1 full circle. Okay, that was the circumference. So just by looking at the radian, it seems like we walked a little bit more than a full rotation. Backwards, because it's negative. And when we convert it to a degree, that kind of confirms it. We know 360 degrees are in a circle. Notice how 390 is a little bit more. So it makes sense that we did our conversion correctly. Okay, we walked a little bit more than a full circle. Let's see if we can find coterminal angles for radian values. If we can find coterminal angles for degrees, we can do the same thing with radians. Okay, so let's check this one out. Find one positive and negative coterminal angle with this starting radian amount. Do this by first converting the given angle into degrees. I know we're more familiar with degrees, so probably converting it won't be that difficult for us to do. But the next one, we're going to try to do it without converting. Okay, that way we can get used to these radians. So let's try to convert this radian measurement first. If we convert a radian to a degree, we need 180 over pi. What's our equivalent degree measurement? Yeah?
Negative 240.
Negative 240, good. All right, so we're going to try to find one positive coterminal angle and one other negative coterminal angle. Which one do we want to try to find first? Coterminal angles differ by some multiple of 360. So the question is, do we want to add 360 first, or do we want to subtract 360 first? Doesn't matter. Maybe we'll try adding. All right, so negative 240 plus 360, we'll get 120 degrees. So let's see if we can draw that in our standard position. We'll start with the initial side on the positive x-axis. And 120 degrees would bring us into the second quadrant. So we'll draw the terminal side. Can we figure out the reference angle, how far we are to the closest x-axis? That would be this little angle right there. Yeah? It would be 60 degrees. Perfect. All right, so there's one positive coterminal angle to negative 240. They would land in the same exact spot. They would have the same exact reference angle. It just depends a different angle of rotation or path. It would still get us to the same spot. Let's try a negative coterminal angle. So we'll subtract 360. So that would get us to negative 600. All right, initial side, Since we are drawing a negative angle, we're going to draw one backwards. If we do a full circle, that's 360. Let's see if we do another 90. Let's see. That'd be 450. Another 90 would be 540, but we're not quite at 600 yet, so we're going to have to go a little bit more. Notice how we'll land in the same spot. So reference angle to the closest x-axis, we should have the same 60 degrees. We doing okay? Okay, we're going to try to do the same thing. So we're starting with the same radian value. This time we're going to try to draw them without converting it to degrees. All right, so if we were to take 360 degrees and either add it or subtract it to our starting angle, what's equivalent to 360 degrees for radians? 360 is all the way around for the degree measurement, but what's all the way around for a radian? Yeah? 2 pi. All right, so let's start with the negative 4 pi over 3. And instead of adding 360, because we're not working with degrees anymore, we're working with radians, we'll add 2 pi. Remember, that was the circumference of the unit circle. 2 pi all the way around. So this is when it can get a little tricky, because notice how we're working with fractions. And we're going to have to be familiar with our fraction work. If we're going to add 2 pi, we're going to have to convert it to a common denominator. That way we can get, or we can add these fractions together. So getting a common denominator of 3, we would have to multiply 2 pi on top and bottom by 3. So negative 4 pi plus 6 pi would give us 2 pi over 3. So we could probably assume that this 2 pi over 3 is equivalent to the 120 degrees, because we added 360 in that case. This time we're adding 2 pi, then these must be equivalent radians and angles as well. If we try to draw that, it should look very similar to the one that we just drew up here. We're going to have our initial side, and let's draw the angle of rotation. Now, on the previous page, we said 90 degrees was pi over 2. Notice how 3 pi over 2 is a little bit more than that. So we're going to have to go into the second quadrant a little bit. Let's see if we can figure out what the reference angle is. Can we convert 60 degrees, which was the reference angle previously, into radians? Can we do that real quick? Take 60 times pi over 180 and see what we have left. Leave it as a fraction though, we should still have the pi in there. You find it yet?
Pi over 3.
Pi over 3, good. All right, let's try the negative one. We'll take negative 4 pi over 3, our beginning angle, and we'll subtract 2 pi from that. But we're working with fractions, so we're going to have to try to get a common denominator. So that would be minus 6 pi over 3. Negative 4 pi minus 6 pi, we have negative 10 pi over 3. All right, so negative 10 pi over 3 must be equivalent to negative 600 degrees. when we draw the angle, it should look exactly the same as the previous one. So we'll start in that initial side, angle of rotation. We'll land in that second quadrant and draw the terminal side. Since these are coterminal angles, they land in the same spot, and they also must have the same reference angle. So the reference angle for this one would be the pi over 3 as well. All right, so let's make sure we are understanding the similarities and differences of degrees and radians. Degrees is measuring the angle. Radians is actually measuring the distance you would walk around the circumference of the unit circle. But that distance you walk is directly related to the angle measurement if you were measuring it from the origin. So they are related together. We have two different ways to measure an angle specifically in this unit circle. So degrees is what we're used to. Radians is what we're going to try to get used to. If you are having trouble with getting used to radians, I have no problem with you converting them to degrees, okay? But make sure you convert them back to radians. If you're asked about a radian, you should end with a radian. Does that make sense? Okay, so I understand if we're going to have some trouble, and tomorrow we'll practice a little bit more with the converting. Okay, but remember, there's two different ways, so we're going to try to get used to the new way with radians. All right, we'll end there for today.